Hello, students. Mr. Gray here to teach you about how to find the equation of a perpendicular bisector when you are given the endpoints of a segment. So I go ahead, I'm going to dive right into this. You can see here I've created a three-step process for what I think is the most efficient way to solve a problem like this, where you are given the endpoints of a segment and asked to find the equation of the perpendicular bisector for that segment. So what do we got here? Step one, you're going to be looking at that segment and determining the slope using the slope formula, which is right here. Step two, you're going to find the midpoint of the segment using the midpoint formula, which is right here. And then at the very end, once you know the slope and the midpoint, you're going to plug the midpoint and the perpendicular slope into this equation right here, which is point slope form. Now, the reason I highlighted, or I guess underlined perpendicular slope, is because there's kind of a step involved with that. You got to switch the slope of the segment around into the correct perpendicular slope. Okay, so this is a three-step process I'm going to be using. I'm going to give three examples on how to do this. I advise that you pause the video here and write down these steps before you follow along with the first example. All right. Okay, students, now hopefully you have those steps written down. Let's dive into this first example. Find an equation for the perpendicular bisector of the line segment whose endpoints are 3, -7, and -9, 3. All right, well, let's dive in. I always like to begin by labeling my points so I don't mix up what's going where. So I'm going to start by labeling this first coordinate as x1, then y1. That doesn't really look very much like a y. How about a y1? There we go. X2 and y2. Again, the reason I do that is just so I don't make a silly mistake and mix something up when I'm plugging it in later. All right, now let's follow along with those three steps. Step one, we're going to figure out what the slope of this segment is. So slope is equal to, we got a big fraction. We're going to plug in y2, -3, minus y1, which is -7. Well, minus a minus, that's going to switch that to +7. On the bottom, we're going to do -9 minus 3, x2 minus x1. Let's simplify this fraction here. -3 plus 7 is 4. On the bottom, we got -9 minus 3. That's -12. And that right there will simplify -4/12 to -1/3. Okay, we have a slope. I'm going to leave that sit there for a minute. We'll come back to that and use it later. Step two. Now we need to find the midpoint. So midpoint formula, big set of parentheses. We start with our x in the front. So let's see, x1 is 3 plus x2 is -9, so 3 minus 9 for our x coordinates. For our y coordinate, we're going to combine those y's. Let's see here, -7 minus 3 over 2. And that's both of those end up being subtracting because we're adding a negative value, which is the same thing as subtraction. So let's go ahead and simplify this. I'll start with the x first. 3 minus 9, let's see, that's -6. Divide -6 by 2, you get -3. Over here, -7 minus 3, that's -10. Take -10, divide by 2, you got -5. So there we go. We finished step two. We now have the slope and the midpoint of our segment. Let's go to step three. I'm going to kind of do this one off to the side here so I can draw some arrows and whatnot. So step three, we have our equation point slope form. Y minus y1 equals m times x minus x1. And we're supposed to plug in our midpoint and our perpendicular slope. Let's start with that perpendicular slope. Right here, we have the original slope of the segment, but we don't want that slope. We want it to be perpendicular. So to remind you, for a perpendicular slope, you have to do two things. You have to make it the opposite sign and the reciprocal. So opposite sign, well, let's see here. That's going to be positive. Reciprocal, we can flip that fraction, make it 3 over 1. Now we're talking. 3 is the perpendicular slope, which we will plug in right there for m. Let's see what else we're going to plug in. Well, y minus, I need a y1 value. How about this -5 from the midpoint? That's going to go right there. So minus a minus makes this +5. equals, let's put that slope in there of 3x minus, now I need x1 again coming from the midpoint, dropping that in there, minus -3 makes it +3, and we are done with this problem. If you are one of my students and you're working on delta math, it will accept this answer in point slope form, which is fantastic. So we're done. So there you go, 3-step process. Let's review really quick. We started by finding the slope. It was -1/3. Then we found the midpoint. It was -3, -5. We plugged in the perpendicular slope, so we did the opposite reciprocal, and we plugged in the midpoint, all into point slope form. And we're done. 3-step process. All right, there's your first example. Let's try another. Okay, example number 2. Find an equation for the perpendicular bisector of the line segment whose endpoints are -3, -8, and 5, -4. Okay, I always start these the same way. I'm going to go ahead and label these coordinates. I've got x1, y1, and x2, y2, just so I don't mix them up later on. Step 1, we need the slope of this segment. Slope is equal to, we're going to do y2 minus y1, so minus -8 makes that +8. On the bottom, we're going to do x2 minus x1, so make that into +3. Let's simplify this. -4 plus 8 is 4. 5 plus 3 is 8. And that fraction reduces to 1/2. Step 1, done. Moving on to step 2. Now that we got that, we need the midpoint of this segment. All right, starting out with our x coordinates. x1, -3, plus x2, which is 5/2. For our y coordinate, -8 minus 4/2. Just like that. Plugging everything into the formula. Now let's simplify. On the left for our x, -3 plus 5 is 2. 2/2 is 1. There's our x coordinate. On the right, -8 minus 4, that's -12/2 is -6. Excellent. 2 out of 3 steps done. We've got the slope and the midpoint of the segment. Time for step 3, where we plug it all in. Step 3, get our handy dandy y minus y1 equals m times x minus x1 all set up. And let's see what we're going to plug in. Remember, we don't want this. We've got to change it over into the perpendicular slope. So opposite means negative here, and reciprocal, take 1/2, flip it over. You've got 2/1 or just 2. So this right here, -2 is the perpendicular slope we're going to plug in for m. We're also going to plug in the values from our midpoint. So let's put this all together. Y minus, well, I need a y1. It's -6. So that switches to +6. Equals, putting that slope in from above, -2. X minus, we need an x1. It's coming from our midpoint right there. We're going to plug in 1, and that's positive. So ends up being x minus 1 because the formula has the negative in it. And there you have it. Example 2 complete. Y plus 6 is equal to -2 x minus 1. That's the line that would perpendicularly bisect the segment given. Okay, 2 examples. I'm going to do one more for you in this video. Let's go ahead and check out example number 3. Okay, example number 3, the final example for this video. Same setup, same type of question, same steps. Let's dive in. Find an equation for the perpendicular bisector of the line segments whose endpoints are 7, 1 and -9, 9. Well, hopefully you're catching on how I'm going to start this out. First thing I'm going to do is label these. So it looks like I've got x1, y1, then x2, y2. All right, now let's dive in. First step, we need the slope of this segment. Slope is equal to y2, 9, minus y1, that's a 1, over x2, -9, minus x1, -7. Woo, tripped over my words there. Let's go ahead and simplify this. 9 minus 1 on top, that's 8. On the bottom, negative 9 minus 7, that's negative 16. That fraction reduces to negative 1/2. All right, there's the slope of the segment. Leave that there for a minute. Moving on to step 3. Step 3, we're going to find the midpoint. Go ahead and set this up. The first fraction has our x values, so that'll be 7 minus 9 because we're adding a positive to a negative. And then the second one will have our y values. That'll be 1 plus 9. Let's go ahead and simplify. For our x coordinates, 7 minus 9, that's negative 2. Divide by 2, you get negative 1. On the right side for y, we have 1 plus 9 is 10. 10 divided by 2 gives us 5. So it looks like the midpoint of this segment is negative 1, 5. We've got a slope of the segment. We got a midpoint of the segment. We got a number here that I wrote completely out of order. My goodness, that's step 2. What am I thinking? Let's go ahead, now that we've got that correctly labeled, check out step 3 here. So this is the final step where we're going to be plugging some stuff into y minus y1 equals m times x minus x1. We're going to start with that slope. We know we don't want the negative 1/2. We need the perpendicular slope. So first thing, switch the sign, make it positive. Second thing, flip the fraction. That looks like 2 to me, and 2 is the slope we will plug in. All right, got the slope. Let's start plugging in everything. Y minus, grab your y1 value. That's from your midpoint. So a 5 equals m. That's our slope. We just found out that's 2. And then over here, x minus x1. Well, minus negative 1 looks like a plus 1 to me. And there we have it. We are done. That equation right there would be the line that perpendicularly bisects the segment with the endpoints given. All right, you've seen 3 examples now. You've seen the 3 steps that it takes to solve this problem. I hope you found this video helpful. Thank you for watching.